Hi guys, so today we're going to be talking about confidence intervals. We'll be understanding how all of those numbers and percentages we learned fit into the statistical model and what exactly we are doing in statistics to get the results that we get. Okay, so let's begin. So, first of all, let's start with our normal distribution curve. This is our population, okay? And so first thing we decide is a confidence interval, okay? And usually the confidence interval is that the limit of that interval is decided by alpha, and alpha is either 95% or it's 99%. Okay, this is just the convention. There are researchers out there who use 60%, 70%, whatever it is. That is depending upon you as the researcher. Okay, so now let's go with this 95% one because that's usually what we see. Okay, so 95%, we know that's around 3 standard deviations, right? So, okay, and here will be our mean or average, okay? So what it basically means is that anything that falls in this 95% limit is essentially similar enough to the mean, okay? So the best example that I have come up with for this is that of wrestling, okay? So you are regulating a wrestling competition, okay? And your mean for the weight categories, let's say one weight category, the mean is around 150 pounds, okay? Yeah, and now, so the limit here, let's say 3 standard deviations above is 152 pounds, and here it's 148. Okay, that's just where these numbers fall on the number line. So now, if a wrestler comes to you and their weight is 152.1, that means that they fall outside this zone. They fall outside your confidence limits, right? So they fall over here. So what that basically means is that they're different enough from this mean to not be considered the 150 pounds that they need to be for this category, okay? And that's based on you because okay, in the similar situation, okay, if one wrestler is weighing 151 pounds, okay, so they fall somewhere over here. Okay, so it's not the same as 150, but according to you, it's similar enough to let them compete in the 150 category, okay, because it falls within your confidence limit, okay? So when the wrestler comes to you and asks you, hey, why did you not let me compete? I'm only 152.1, then you have to say that, hey, this is a limit I had set for my competition, and that's why you can't compete. If you were 151.9, you would still be in the limit, and I could have let you compete. But you are just outside the limit, and I can't let you compete because you have to draw the line somewhere. And that is the whole game of statistics, okay? Now, if we look at a PT example, okay, so let's say you're comparing swelling before icing and after icing, okay? And these are your limits over here. And you began with a patient with 4 centimeter of swelling, and the swelling can either go up, let's say 6, or it can come down 2 centimeter, okay? And now you want to see if after a week of icing, the difference it made to the swelling was even enough to call it a difference or not, okay? So now, let's say if the patient had 3 centimeter of swelling after your treatment, so they fall somewhere here, okay? 3 centimeters somewhere here. So they're similar enough to 4 for you to not actually say that there has been any difference made, okay, because it's within the limit. Now, if this patient had, let's say, 1.9 centimeter of swelling, so it falls outside this zone over here, 1.9. So then you could say, hey, 1.9 centimeters, that's still some swelling, but it's different enough from this 4 centimeters to be considered that it's not the same, okay? So this is the entire game of stats. So anything that falls in this region is said to be that the null is accepted. And anything that falls outside these two regions, you say the null is rejected, okay? And that is all because the null hypothesis states equality, okay? So let me introduce that concept. So the null hypothesis always states that something is equal to something, okay? Null always states equality, okay? So in this case, your null will say that whatever this mean is, anything that falls within these limits inside is equal to the mean, okay? So within the 95% confidence interval, everything is equal to the mean, okay? So, which is why when something falls here, you end up accepting the null. And as soon as anything falls outside of here, you reject the null. Okay, so this is the entire game of stats. And yeah, this is the entire basis of it. That if it's different, is it different enough according to the limits you set? Okay, and yeah, let's continue with the next concept in the next video.